Hello and welcome back. In this tutorial I'll show you how to split an intensive operation over a number of frames using a coroutine in order to maintain a reasonable frame rate. Now I figured a good way to do this would be to start with the code placed in methods as normal and then show you how you would change this over to a coroutine. The first thing we can do is look at the code here. This is just some dummy code effectively. It's not really doing anything. In start we call get all AI orders. In get all AI orders, it will iterate through this for loop. It'll iterate 20 times. Each time it will get an individual order. Now this is where the heavy logic would be. There are a variety of things you need to do to get a potential order for an AI. It obviously doesn't make any sense to go into them now, but this is where the heavy logic is. Now you also note there is a debug statement in the update loop. First we'll just run it to see what happens, just to see what debug information comes out, so we just run it. Now I have a game object with this example script attached to it. And looking at the debug information, we can see that get all AI order is here. That's been called. Next, it iterates, it debugs get all individual order 20 times. So it goes through here, it iterates through this 20 times. Then we can finally see that it updates, that an update is called so that the frame has ended. So you can see there, if that process takes a second, the frame isn't going to update for a second, and that's it's untenable frame rate of 1 FPS. It's completely useless. So what we'll do is focus on converting this over to a coroutine. It's very simple to do. Now, if it's just called within the script, we don't need a public. We just say enumerator get all AI orders. You'll notice that there is an error there. Not all code paths return a value. All coroutines need to return something. It can be null. In this case, what we're going to want to do is we'll iterate through once, we'll get the individual AI order, and then we'll yield return new wait for end of frame. So that will allow update. That will pass control back, and it will allow the update to be completed. There's one more thing you need to do, but this is possibly worth mentioning because you could be scratching your head for a while if you're not aware of this. Okay, we can see now that the update loop, it hasn't actually called the coroutine, and it hasn't thrown an error either. That's something that could potentially catch you a couple of times. You actually need to start the coroutine with the command start coroutine. You can start it by calling the coroutine name. It has a slightly lower overhead than the alternative, which is passing a string, and there's also the risk of passing a string that maybe you type it wrong or something like that. It could be another tricky to find error. So we'll build that now, and we'll hit play again. Just clear that out. Hit play. See, I don't know if it's okay. It's definitely run its course by now. So what you can see here now, it's called get all AI order, which is now a coroutine here. It is debugged information from get all individual order, which is here, and then it is called update I'm not quite sure why it's called update twice the first time. It's not really a huge concern. So it's alternating an update. So it's allowing the frame to be completed. It's getting another order. It's allowing the frame to be completed, getting another order, allowing the frame to be completed. So using that sort of structure, which is really just a matter of changing a couple of lines, that could make a big difference if you have something very intensive you need to spread out over a couple of frames. And that's pretty much it for this tutorial. I'll look at another common use for coroutines in the next one, and I'll see you then.